All right, so we're diving deep today into volcanoes.
Always a hot topic.
Yeah, literally. But we're going even deeper than just eruptions and lava flows. We're talking about where that molten rock, the magma, actually comes from. We've got some cool info pulled from a text all about the generation and rise of magma. And you know what? It's not from the Earth's core like a lot of people think.
Yeah, that's a pretty common misconception.
Right. So where does it actually come from then?
Well, get this. Magma actually forms in the upper mantle. And it's not just hanging out down there in a giant pool of lava either. It forms through something called partial melting.
Partial melting, huh? So only certain parts of the rock actually melt.
Exactly. It's not the entire thing melting all at once. Imagine like a chocolate chip cookie.
Okay, with you.
The cookie dough is the solid rock of the mantle.
Makes sense.
And the chocolate chips, those are the different minerals in the rock. And just like chocolate chips melt at a lower temperature than the dough, certain minerals melt at lower temperatures than others.
Ah, I see. So as the temperature rises down there, only those minerals with the lower melting points actually liquefy, and the rest of the rock stays solid.
You got it. That's partial melting in action.
Okay, that's actually a really cool way to picture it. But what's causing all that heat down there in the first place?
Well, believe it or not, a big part of it is radioactive decay.
Wait, seriously?
Yeah, there are elements like uranium, thorium, and potassium naturally found in the Earth. As these elements decay, they release energy, and that energy is heat. It's happening constantly. Over time, that heat builds up and creates those incredibly high temperatures we find in the mantle.
Wow, so something as tiny as an atom decaying is contributing to something as powerful as a volcano.
Pretty amazing, right?
Totally. Okay, so now we've got this magma forming in the upper mantle. It's lighter than the surrounding rocks, so where does it go?
It rises, like a hot air balloon.
Makes sense.
But its journey to the surface isn't always so simple.
Oh, really? Why not?
Well, there are a few different ways magma can make its way up. Sometimes it forms these slow-moving blobs, we call them diapers.
Diapers.
Yeah, they basically push their way up through the surrounding rock, kind of like a lava lamp.
Okay, I can picture that.
Other times, it squeezes into cracks and fractures in the Earth's crust. These are called dikes.
So, like, it's taking advantage of any weakness it can find.
Exactly. And sometimes it can even pool at the base of the crust, accumulating over time.
So these different paths, I'm guessing they influence what kind of volcanic activity we see on the surface.
You bet. The way magma rises affects everything. The type of eruption, the shape of the volcano. If you've got slow-moving diapers, you might get a more gradual, effusive eruption. But if the magma is shooting up through dikes...
Then things could get a bit more
explosive, exactly. It's all this intricate interplay between the properties of the magma itself, the path it takes, and the surrounding geology.
super fascinating. Okay, now let's talk about magma chambers. Are they really just giant underground lakes of lava just waiting to erupt? Or...
Yeah. I wish it were that simple. They're not these static pools of molten rock. They're more like dynamic zones. The magma is constantly moving, crystallizing, and changing.
Interesting. So where do they usually form?
They often form in zones of neutral buoyancy.
Neutral buoyancy.
Yeah, where the pressure from the surrounding rock balances out the pressure from the magma inside. It's kind of like a pressure cooker.
Okay.
So the intense pressure keeps the magma in this semi-molten state, a mix of liquid magma and crystallized minerals.
So not just a comfy spot for the magma to chill out in then. So what eventually makes these pressure cookers, well, erupt?
That's the million-dollar question, isn't it? That's what makes volcanoes so unpredictable and fascinating.
Yeah.
There isn't just one single answer, but we know a few things. For example, fresh magma injecting into a chamber can definitely shake things up. It increases the pressure and could trigger an eruption.
Makes sense.
And remember those volatile gases we talked about earlier?
The ones released during radioactive decay.
Well, they're also dissolved in the magma. As the magma rises and the pressure decreases, those gases come out of solution. It's kind of like when you open a shaken soda bottle.
Oh yeah, that's a great analogy. So all that built up gas pressure has got to go somewhere. But what about external factors? Can things like tectonic activity trigger eruptions too?
Absolutely. Earthquakes can shift things around, creating stresses and fractures in the crust that can destabilize magma chambers and open up new pathways for magma to rise.
Wow, so it's not just what's happening inside the Earth that matters.
Nope. Even things like heavy rainfall or snowmelt can change the pressure balance within the crust and potentially influence volcanic activity.
So it's this incredibly complex interplay of both internal and external factors that can ultimately lead to an eruption. We started talking about tiny atoms decaying in the mantle, and now we're talking about these massive forces that shape our planet's landscape.
Pretty incredible, right? It just goes to show how everything is connected. And honestly, there's still so much we're learning. We've touched on some known triggers, but each volcano is unique. It has its own personality, its own set of circumstances that influence how it behaves.
It really makes you realize how much more there is to discover. It's pretty humbling, and it definitely leaves me wanting to know more. As we wrap up this deep dive, I can't help but wonder about all those other mysteries still hidden beneath the surface. What other subtle forces could be playing a role in triggering these incredibly powerful events?
Yeah, it's really a reminder that the Earth is this living, breathing system.
And even something as seemingly straightforward as a volcano is actually the result of a crazy, complex web of interactions.
Definitely something to think about.